Welcome to our third session for the FRC programming. And
that way they can see that you're trying to.
We might ask that the participants mute. There are one or two participants that may not have muted. And that will just help us to keep everything in order. We're most appreciative of all the FRC team members who have joined us from all around the land this evening. And it'll be great to see all the team members. I saw them filling in a few moments ago. If you just joined, kindly share your team member with us, and that will really help us to understand the variety of teams that are represented on our session here. This is our third session in a series, the first part of which will end in mid-December. Our weekly sessions are aimed at taking relatively new programmers on a journey towards being able to code Java for FRC. So as such, this is not a full Java course. We're aiming towards those elements of Java that will help us to achieve our objective, which is programming in an FRC environment. Even so, we will get an opportunity to think about and work with a number of very important Java concepts. So the outline of our evening, we already talked about sharing our team numbers. Looking at FRC coding, the first two sessions largely focused on the Java language, and we'll do that a little bit more this evening, but also during our sessions, we will be moving towards more problem solving, speaking about things that you can do to work with the Java and to solve typical problems that arise when you're working with the Java. We will look this evening at designing programs in a little bit more detail, speaking a little bit more about some of the things we talked about last time, particularly classes, methods, variables, and libraries. And if time allows, we'll review a few of the Java programming elements inside one of the classes that we make this evening. And later this evening, we'll announce a coopertition, a little Java-based coopertition that will be the motivation, perhaps, for you to learn Java. The aim of our coopertition will be for us to help each other to learn enough about Java.
It's saying failed to detect your speaker.
Saying, but you shouldn't.
We will perhaps just ask, I think, those who are trying to troubleshoot the sound, well, maybe they're not hearing us, but anyway, hopefully that will work out. Our cooperation will see each competitor or team create a Java method that will be inserted in a bigger program, and there will be a tournament between the Java methods. And that will be our cooperation. And we'll see how that all will work. And more details on that later. Our schedule again, from October to February, we're learning how to use Java in an online environment here on the Zoom call. And in the meantime, we're hoping that the participants will install FRC Java. And if you're not sure how to do that, you may go to your browser and search for FRC control system. And it will bring you to some web pages that will show you how to install this, like the software for programming in Java. The software that you need to install is called VS Code. If you install VS Code from the VS Code website, it will not be sufficient. You need to follow the special directions in the FRC control system software. I will show that a little bit later when we're talking about the things that we'll need to do to get prepared for our later sessions. So intermediate and advanced topics will happen later on. So if we recall last time, we spoke a little bit about variables, operators, arrays and lists, decision structures, loops, methods, and different keywords. Maybe it might be timely to just mention a few of those or show a few of those again in a little bit of a Java code. I'm going to go here to our Java REPL site, REPL Java. And here is a ready-made Java installation. No work required on your computer except a working browser. And maybe we can code a few things into here. All right, I've just input 3 variables here using 3 different data types or variable types. And one is our integer. The next one is a floating point number. And the third one is a string. Let's see if they all print out fine. I'm going to try running the code now. Oh, and I've already missed one of my semicolons here. Probably because I put 2 brackets down there. There it is. Okay, so there's a simple program that declares 3 variables and prints 3 variables. If we go back to some of our other ideas that we talked about, there's some variables. What about some operators? So we can do some decisions on our variables. If, for example, number is greater than 0, we can put that here. Then we do something. In this case, we're going to indicate that. Okay, so the first thing that you may have seen is this is a decision structure. That's one of the ideas that we talked about last week. This is our if, and if the number is greater than 0, we're going to put in a message, the number is greater than 0. But we can also do this, number minus minus. This is a assignment operator, which decrements. It reduces the value of number by 1. And just to prove that, we're going to print the value of the number afterwards. And let's see if this works. And we should see it. And we know that the number is 5. Then that gives us the message the number is greater than 0, but then we used an assignment operator to reduce the value of the number by 1, and then we print it out again. So there's an assignment operator, but we can also do this. We can use the AND, sort of a logical operator. Let's try this one. If number is smaller than 0 and name is equal to Ted, then we can say something else like the special condition is met. And then we can do something else. Maybe I'll just increment the number this time. All right, so there are two decision structures here. Here's the first one. Here's the second one. The second one uses a logical operator, which is the AND operator, which is 2 ampersands, the little symbols above the 7 on your keyboard, or in most keyboards anyway. And we can try this. Now we see that the number is not less than 0, so we should not expect anything to happen here at the moment. Even though the name is Ted, it's not going to do anything. However, I might change this AND to OR, which is 2 pipes. They're the little symbol, usually located somewhere near your enter button on your keyboard. Vertical lines, often referred to as pipes. Now the special condition is met because I put an OR there. It was only sufficient, or the fact that the name was Ted was sufficient to make that entire expression true. But if I make this Sue, for example, then this is not going to run again because that's not Ted. But I can make the number less than 0 by assigning it a value of -5. So even after we increment it, it will be -4. And then it says the special condition is met. Oh, actually, it decremented and then incremented. Anyway, you have to carefully trace through the execution of the code to find out what is the value of number when each of these statements executes. And when you design your code, you have to have that in mind. This was just a little bit of a discussion about some of the ideas that we talked about last week. Perhaps one more idea out of this list. Loops will be very, very useful. So I'm just going to make a little loop like we did before. And we'll do this. So we'll declare an integer value I inside the loop. Int I is equal to 0. That's our starting or initial value. And here's the ending condition. I is less than, say, 100. And then we'll have some kind of change in the value of the variable brought on by the increment operator, I++. And in this little loop here, I'm going to just say system.out.println I. Just print the value of I. And as you may recall from last time, that will print the numbers from 0 up to, but not including, 100. Let's try that. So all of those first things happened. You'll see the first part of the program did execute, and then it printed all the numbers from 0 up to 99 inclusive. Just a few little examples here to illustrate some of the ideas that we've already done. I'm going to just save this code for later, just in case. I'll just start up. There, I just saved the sample code there, and that will help us to review it later. I'll see if we can post it. All right, that's a little review of our code from last time. Methods, we will surely get onto this time, and maybe another time we'll review our arrays and our lists. Here is the same slide that we've seen for the first 3 sessions, but each time I've just added a little bit to the slide. Thinking about our vision for where we're going with our FRC software deployment. This time you may recall that I didn't have, well, last time I didn't have the camera and the LED ring installed here. And so I have a little camera, and it's connected by USB to our Roborio. And on some cameras, they go right into the center of an LED ring, which more often than not will use green light to spot targets on the game field. This LED ring is also connected to another little microcomputer called an Arduino in many cases. At least that's how our team did it. The Arduino generated the code to create green light out of our multicolor LED ring. And this is just one more aspect of the computer programming setup for our FRC robot software deployment. So you may see that Python will go on to the coprocessor, though Java is also possible, and a version of C language will go into the Arduino. I haven't shown the Arduino here. All right, this is just a vision as to where we're going. And tonight, we'll also speak a little bit more about GitHub and see if everyone may start the process of getting a GitHub account and preparing to share code online. So the Java language and working in Java. Oops. In our first two sessions, we talked about the basic features of Java, and this section is a little bit more about putting Java programs together. And starting this evening and session 4 and beyond, we will get a little bit closer to doing Java and FRC. A few of the examples from this evening's sessions are specific to the FRC Java programming. That will really help us to see that we're making progress towards being able to program our FRC computer or FRC Java for our FRC robot. So we stop a little bit here at computer programming paradigms. How do we put together a computer program? I think that's an important topic to consider. I'm going to give an example here of Commodore 64 BASIC. Back in the mid-1980s, there was a very famous computer company called Commodore that exploded onto the scene with popularity, and they produced many, many, many popular computers, particularly from about 1981 till about 1990 or so, after which the Commodore company rather quickly disappeared. It might be interesting for you to see why, but that's another story. The Commodore 64 BASIC is a very good argument for organizing our computer code. And I actually have a Commodore 64 BASIC emulator right here on the computer. So here's a Commodore 64 BASIC program. I'm going to list the program. And you can see that it just goes on and on and on. We didn't really have a mouse or keyboard back then. We had to do all text-based sort of interaction. The whole point of this, though, is that you'll see that the code just goes on, and it's not really easy to follow what's happening in the code. And
William, we're not seeing your code. We're seeing the slideshow.
Oh, really?
Oops.
Oh, so sorry. Here we go. Try that one more time. Now, can you see it? I think I inadvertently unshared.
Yeah, it's good now.
Okay. So I'm just going to list this code one more time as the Commodore 64 programming. Every line of code, you had to put a number, and the numbers were executed in order. And so you see there, but the code is not really organized, not very well at all. And you really had to search through the code to figure out what to change and how to continue programming. It really wasn't organized so well. And so that's the Commodore 64 language. My student a few years ago recovered this code from my floppy disks, my data from 1988, actually. So I was really grateful for that. But I think the example here is just to motivate, well, why should we care about programming paradigms, how we organize our code and things like this? So I'm going to share something slightly different now. Here is, trying to get at it without unsharing the screen. All right, so here is an online repository called GitLab. It's very similar to GitHub. And my students and I, we generated this repository of code over numerous months in class and outside of class. And I'm just going to give an example of some code. This code is actually in Python, but the purpose is just to illustrate how it's organized a little bit differently. So earlier computer programmer languages were just all in one big chunk. But now we see this is a procedural language or a procedural organization. It's not really a procedural language. Python is also object-oriented. In this particular version of the program, we define some variables and we define a few more variables. And then we have what are called functions. And these are similar to methods that you see in Java. And each function has a chunk of code that is readily visible and easily discernible from the rest of the code. And once we've defined all our functions, then we have our main loop here. And the main loop calls function f, for example, and it uses all the variables in its calculation. So this is a little bit easier to understand this code, but it's still not object-oriented. And we will take a little bit of a look at some other code here, the FRC Java. In our FRC programming, we're doing something called object-oriented programming. And we already talked about that last time. We group our code off into what we call objects or classes. And inside a class is a group of variables and methods that are related and are easily related to other items in the program. The code is a little bit more organized. So in FRC Java, we have three basic organization schemes for our code. One is called a timed robot. Another is called a command-based robot. And another one is called the iterative robot. And let us just take a look at some of the example of this code right here. This one right here is I believe it's probably the timed robot. That's what I set up there, I believe. Let's see. Okay, yes, this is a FRC timed robot. And how is the code here organized? Well, there are two main files. One is the main file. And if we look here, this is not too much different from what we saw in the first 2 weeks. It's almost identical to what we've seen. There's a main function in the class main, and there's this public static void main, which is the constructor. This is the code that is called when we make a new example of the class main. There's this new private main thing here. We didn't talk about that before. And in our constructor, we make a new instance of a robot using the robot base class. And there's a class called robot base, and it has a method called start robot, and it starts up a new robot. And where does it go to get the information for this new robot? Right in here. Here's our robot, and this is the basic definition of an FRC robot. And right in here, how does it go together? First of all, we specify that this is a package called FRC robot. It's a collection of files in a directory that are related to each other. And in this case, it's the frc.robot package. And in the directory are a bunch of sub-files, if you want, that can all relate together to do the robot code. Right now, there are only two such files in this directory, the main one, which calls upon the robot one. So if you do a timed robot, what's very nice about this, most of the programming can be done in this main class here. And we can just override a few of the methods of the basic robot class with our own code. So each of these methods, like the initializing method, robot init, that's already defined for us in the robot class. And we can override it, make our own coding right here. So there's one thing that comes with the robot class, what to do when we start up the robot. It's called robot init. And this one is a very commonly used one during the 2 minutes and 15 seconds of the game. Then we do robot periodic. And this is called perhaps 100 times a second during the game. And it checks the sensors and it checks for the game controller input and it acts accordingly. And then we have the autonomous init and autonomous periodic. These are similar. This autonomous init, it's only executed once. It sets up everything we need to do to operate the robot without human input. And then during the 15 seconds at the very beginning of the game, this autonomous periodic executes. All right, so we see here the architecture of a basic robot program called a timed robot. And this is one programming scheme that you may use. And it is definitely an easier one to begin with. And we can use lots of sample code from other robotics teams and from examples we find on the internet and modify this as we see fit and piece by piece build up a working set of robot code for our robot. All right, so there's one such scheme. And since we're here, I'm going to actually start up an example of the command-based robot. So we'll talk a little bit more about how to do this later. I'm using VS Code, which hopefully many of you will have installed by now. If you haven't, by the way, please feel free to email and we can do some troubleshooting. I'm going to use a special shortcut, Control and Shift and P. This gives me a menu of functions I can do within my robot programming software package. And I'm going to create a new project in the WPI lib. And this is a new robot program. We will talk about this a little bit more. I'm going to show it a few times throughout our series of coding sessions so it will become more familiar. So at the moment, just follow along and see what it looks like overall. I'm just going to make an example from a template. And I'm going to select the Java language. And this time I'm going to try a command-based robot. There we are. I'll get a new folder here, probably right about here, and make a sample command robot. Okay. And the project name, oh, that was the I'll probably call that sample command robot, SCR. Maybe that's not so good. That's a little bit more clear. All right, and my team number. Since I don't have a team number, I'm just going to borrow the team number from my previous team. And there we go. All right, now this is what a beautiful thing is about the WPI lib. It has saved us a lot of work in setting up a basic working robot. Inside this directory called SRC, which stands for source, you can go into the Java directory, and now we see 4 main robot programs: constants, main, robot, and robot container. And then we have a subfolder for commands and a subfolder for command subsystems. So you see right off, the directory structure is a little bit more complicated for a command-based robot, but it is more organized. And if you have a lot of things going on in your robot, it might be advisable to do this kind of robot. Also, if you have a team of programmers, this is a little bit easier to work with because it uses more files. So you can imagine maybe there are 3 commands that you have on your robot that you need to operate. Well, you have 3 programmers, each of them making a command. Well, here's a sample command. And what we have here, it imports the ability to do commands, and it also imports the connection to the subsystems of the robot. You can look at that. And here's a class called example command, and it extends a command-based class, which is already written for us. So a lot of the basic work has been done. So as FRC programmers, we can focus on now getting things done. We're not going to go too much into the details here. We could just leaf through the subsystems. This is a connection perhaps to some of the hardware on the robot. One subsystem we had last year was the wheel subsystem, or the driving subsystem, with the 4 motors that ran the wheels of the robot. And here's a place to collect constants. And then we have our main file and our robot file, and each one of these is in the same package. Each one of these imports the necessary libraries or packages required to do its operation, and they're all connected together in a network of classes, and these classes extend a base class. So the whole point of my discussion here is the way that we organize robot code can make a huge difference. And starting from my Commodore 64 example, you see the code wasn't organized at all. But over time, computer programming languages have evolved to allow these organizational schemes. And you see in this case, with the command-based robot programming, it will take a little bit longer to learn, but it will keep you more organized and thinking more like a computer science, and also able to work in a team. Whereas the basic timed robot is largely in one file and is suitable for a single programmer who's not collaborating with other people, because most of the programming is happening in one file. So hopefully you'll find that a little very large picture kind of overview of where we're heading with our robot code. And hopefully in the next few weeks, we will get into more details about how to work with these coding schemes. So I'm just going to take a moment here and answer any questions that may have arisen.
I don't see any questions yet in the chat there, William.
Good. All right, thank you.
But if you have them, please type them in the
Yes,
chat.
please feel
at any time.
most welcome to answer, or sorry, ask questions and even answer them, as we've had a lot of that so far. So that's really been a great aspect of our learning together. Many of the participants are asking and answering questions in the chat. All right, so that was a little bit about computer programming paradigms, and I'm using this word paradigm a little bit loosely, and I haven't gone into the great detail of paradigms, but suffice it to say the way that we organize our computer code to solve problems is important, especially when we get to more sophisticated projects like making robots work. And today, I just showed you an example of the code base for a timed robot, which is largely programmed in one file, and a command-based robot, which breaks the robot down into numerous files, some of which correspond to the hardware and others of which correspond to operating the hardware. And this allows us to be more sophisticated and organized, though it takes a little bit more effort to understand how to make it all work together. All right, let's go into a little bit about Java program design. And we concern ourselves here with the arrangement of classes, methods, and variables to achieve the aims of a program, much like the discussion has already taken place here. So the programming paradigms that we talked about are patterns of these classes, methods, and variables. And I showed a few of the patterns that you'll encounter. And we'll talk about a little bit of the vocabulary and some of the concepts that are used to understand FRC Java. So here are a few of the words that we may encounter this evening. And anytime something like this is presented, there's a challenge for any of us in a learning environment. So how do we use our time, for example, in a presentation like this, to present as much detail as is necessary to understand without going too deep, but sufficient detail to get the basic idea. So there's always this interplay between how much of one topic to cover and how many topics to cover, just so that we get enough. So here we have objects and classes, methods. We have the word static, public, inheritance, instantiation, override, abstract, and the word extends. Some of these are Java keywords, except that they're capitalized, and others are concepts that we're going to encounter in our discussion.
William,
Yes,
We do have a question because
Sure.
you talked about the timed robot
Yeah.
and the command-based robot, but you skipped over the iterative robot, and we have someone that's asking a question about that. I'm
Oh,
sure
sure.
others are wondering.
I would be very happy to maybe go through that in a future time, because our focus this evening is not the details of those ones, but I'm sure that we will go through that. My whole point this evening was just to sort of highlight some of the different choices that we have, but I think it would be taking us a little bit beyond our scope this evening to go into the details of that. But maybe at the end I could just show the structure of it. That's
Sure.
good. So some examples of public and static variables. Here is one set of concepts that will really help us to understand some of the example code that we see out there in robots, because we'll see the word public and static all through the robot code that you see online. This example here, I have two variables or attributes of the class, static A and public B, and I've set each to a different value. And then I have my main constructor method that prints out the value of A, and then it does this interesting thing here. It creates a new variable M, which is a new instance of the main class. I found this strange when I found this in Java, because in previous languages, I never made this declaration inside the class itself. So it's right here saying that this variable M is an instance of all of this. So it's declaring itself from inside itself. And M is now an example of the main class. So to access the attributes of this main class, we can use the dot notation. For example, I can use m.b to refer to this variable b. And I should be able to print it by doing system out println m.b. Now we can take a little bit of a copy and paste here in the code and go right to our Java Online compiler and see what will happen here when we try it out. All right, so there we have our two attributes of the class. We're going to print A, but then we're going to print B after having declared a new main variable M, an instance of the main class. Let's run it for the moment. And it prints out 5 and it prints out 10, so all is well. Well, here's the important thing here. If I try to print out B without having declared this main variable here, just like this, we're going to see that Java is not so happy. And you may find errors like this happen in your code. And at first, when I started learning Java, I was not sure why some variables would just behave just fine and others wouldn't. Well, I realized later on that part of it is whether they're static variables or public variables. All right, so this static variable, I can just declare it as static and then use it right away without any further consideration. System out println A, everything fine. But since I declared B as a public variable, it must exist within an instance of the class. So what is a class and what is an instance of a class? Well, say we have a human being, we could have class human. Well, in the case of my previous program, I used the name Ted for an instance of that human. So you can keep in your mind, a human is any example of a human being, whereas Sue or Joe or something is an exact example of a human being. Well, the same thing here, main, this is main. It includes A and it includes B. And it includes a constructor method that executes code when we start it up. And here is an instance of main. It's called M. This is a specific example of the main class. And if you want to use B, that public variable, it must only be used inside an instance. So I can only refer to it through m.b here. So to make my program work again, I will have to re-invoke or reconfigure the code just like this. And it runs just like it did at the beginning. So there we have an important distinction between two types of variables, static and public. And we'll see in the next example a little bit more detail about static and public that will help us to keep in mind the difference between these two variables, as you will see both being declared here and there in Java code. All right, let's go back. Oops, wrong way. We'll go back here to the code to our next example. So this is a slightly different example. It's still using a main class, main, but I'm going to do something a little different here in that I'm going to instantiate or create instances of two examples of the main class. So M is the first instance and M1 is the second instance of main. And I was laughing today because when I made this line of code first and tried it out, I always forget this in Java. I always forget to remember. You must always remember, basically, if you're making a new instance of a variable, you have to tell Java what type it is. In this case, it's a main type variable. So something to remember. Also, you need to remember the new keyword. So this new M is an instance of the main class. We declare it just like this. We tell Java it's going to be an instance of the class main, and we're making a new main, and that makes the new M1 a instance of main. So we have M1 and M2 here. Now, the interesting thing that's going to happen, I'm going to change A and B to 20 right here. But what's going to happen? I'm going to print out the values in the first instance, M. So let's trace this here. When I make a new instance of the class, M has a value A, which is 5, and a value B, which is 10. And then M1 has a value of A, which is 5, and a value of B, which is 10. So both M and M1 have A and B equal to 5 and 10 respectively. However, when I make a change to M1, something interesting happens to A and B. And let's look at the code to understand what's happening. So we're going to execute this code here in our Java Online compiler and see what's going on. So if you recall, I changed the value of A and B here. I'm going to make this 30, for example, so we can know which one is which. All right, and I can also change this code a little to do this. I'm going to just say the value of A, M dot A, and the value of M dot B. Okay, so if you recall, I've only changed the values in M1 for A and B. I haven't touched M here, but watch what happens when I run the program. The value of M dot A is now 20, whereas before it was only 5. What happened? Well, there's a very interesting thing. There's only one instance of A for all members of class main. Oops, I kind of lost the edge of the code there. That doesn't help either. I'll just do this. So there's only one instance of A for all members of class main. So if I change A in one member of the class, then A will change in all members of the class. Okay, but B is a public variable, and therefore B is linked to the particular instance in each case. So if I change B in one instance, it does not change in the other. So I'm going to just clarify the output one more step here by printing out all the variables. Here's m1.a and b printed out, m1.a and m1.b. And there we see our output coming out. The value of a in the first two is, the value of m.a is here, and m1.a is identical. Something happened here though. Oh yeah, there it is. The value of m1.a is 20, but the value of m1.b is now 30, whereas the value of m.b is 10. So I only changed the value of m1.b. I did not change the value of m.b. And hopefully this example will illustrate for you the difference between a public variable and a static variable. Each of these you will see numerous times inside your robot code. All right. So those are two examples about public and static variables, and hopefully the code will be made available later for you to play around with. But a very interesting difference between public and static variables. And important to remember, when you're coding, sometimes you'll run into a problem with a variable, and it could be because you're trying to treat one variable like another and forget these particular qualities of public and static variables. All right, so Java inheritance. Two examples for us to look at. At this point, I'm going to start making a shift more towards using VS Code in our examples because the online Java just doesn't show everything as easily. And for some of the examples, we may have to have special libraries installed. So what is inheritance? So for example, in robot programming, we already saw this. There was a class called base robot. And when we made a new robot, we extended that base robot into the class robot. Well, in the little example I'm giving you, a very simple example, I'm going to make a class called robot and then extend that class through a process called inheritance to make an FRC robot. And here is what we call a set of UML diagrams. These are different objects or classes that may be related together in a computer program. So this is a duck, and there are 4 types of duck here. So these 4 children of the duck class inherit the basic attributes and methods of the duck, but they have an overridden display because each one of them is a different type of duck as opposed to the generic duck, which is right here. And there are other things happening in these UML diagrams. These kinds of diagrams are used to help computer programmers decide how data and variables and methods are going to relate together in the class structure of the programs. All right, so we're not going to do a duck example. This is just an example of how different classes are related together by something called inheritance. In our FRC programming example, I already showed you a little bit about the inheritance, and maybe we'll return to that just to review that idea. So let's look at the sample program first. Now on to VS Code. I'm going to open a folder. I've got this program in a separate folder. It's good to become familiar with some of the aspects of VS Code when we're working through it. So I've put a few examples here in my folders. And which one did I use for which one? Sample command robot, sample timed robot. It's looking like I have, oh, is it this one? Robot.java. Okay. I'll just do this one. Oh, that's not it. Try this once again. Java. Here we are. I put it in the wrong folder. Here is a little program. It starts with a main class. It actually doesn't start. The main class is at the bottom here. And this is the part that will be familiar. We have our public static void main constructor method. And in here, we're going to create two instances of two different classes. One is R1, the instance of the robot class. And the second one is R2, an instance of the FRC robot class. And then all we're going to do is display the information about each of these two robots. All right, let's look at the main originating class here. This class robot has just a very basic method called info. And in the info, we just print this is a robot. Maybe we should use English grammar as well as computer programming grammar. Let's put a full stop right there. And here we have FRC robot, just like we saw in the WPILib programming of the timed robot and the command-based robot. We start with some basic classes defined in the system and we extend them. So this FRC robot extends the basic robot class. And you'll see here, I'm doing something called overriding. You'll see this word all through the robot code as well. The original info method is now going to be replaced by this method. So for bonus points, even though I'm not giving them out directly, why would I say this is not a robot under FRC robot? But anyway, now we can see the difference. This one says it is a robot. This one says it is not a robot. So when I display the info of R1, it's going to say this is a robot. But when I display the info of R2, the method is overridden. Let's just put a little note about that here. All right, so the reason that we have an original method here, well, we see this in our robot programming scheme. When we have a robot program, we're going to see an override and then maybe autonomous periodic. Well, the original robot-based class in Java is going to have a bunch of methods like that defined. But when we program our robot, which is an extension of the robot-based class, we're just going to override those basic methods and use our own methods. So in that way, everyone, for example, every human has a name and an address. We know that everyone needs a name and an address. So if we make a specific human, then we can override the basic name and address information with some actual name and address information for that particular human. So that's the organization scheme that we're seeing here. The scheme where we take a predefined class and extend it with our own code using what we call method overrides to get a new method that behaves similar to the old method, but specific to this example. We have many such things happening in Java that allow us to have very sophisticated interaction between different classes and different methods in a computer program. I made this specific example to give you an idea of what's happening when you see the timed robot or the command-based robot or whatever, extending the base class of the robot base class. That's kind of what is happening here. Let us try running. When we have a Java program in the VS Code, there's something we're going to have to talk about later, how to configure this. When I tried to set up this program before, or last week I was setting up other similar programs, I had to do a little bit of configuration to get it working. And we'll talk about it at a later time. But if everything is set up right or correctly, and Java knows where to find its Java runtime environment and software development kit and the like, then when I press play, I should just get the output coming right here. So this is good. You can do a lot of testing then, and you'll get output here. When you're testing an actual robot, though, you may have to do something else because many of these things are actually designed to operate on a real robot, and then we do simulation and other techniques to test before we actually drive our robot around. So what has happened? We made a new instance, or actually we just set up the main class. We didn't make a new instance of the main class. All we did was state that the main constructor method was called, and therefore we get this message. The main class constructor, I think this is more accurate. We've called the main class constructor main. We haven't made a new instance of the main class. Then we could say instantiated. But I can make a little note here in the software code, instantiate a new robot I'm being a little bit repetitive in my English just to show the use of these words. We wouldn't, it's kind of awkward to say instantiate an instance, but instantiate is the verb, and then instance is the noun. This is an instance of the class robot. And then here, R2 is the instance of the class FRC robot. And then we call the only method in each of them and see that there is a difference. This is a robot, this is not a robot. All right. That's our main class with two subclasses or two related classes, robot and FRC robot. In this case, we're using inheritance. So the FRC robot inherits the information, and we could actually say arguments or attributes and methods of robot. Well, in this case, there are no attributes and there's only one method, and that's it. And that's an example of inheritance. It's just like a child may inherit some qualities from a parent, or a certain type of car may inherit certain qualities and attributes from a previous model of the car. And there's our example. All right, back to our presentation here. And we can briefly return to our timed robot and command-based robot. I'm going to show again a navigation through our VS Code integrated development environment and find the code for these ones again. Back here, I'm not showing here the directory structure that I need, so that's okay. I'm going to go and open my folder. And I'll go back one level. There's my sample timed robot, and I'll open up this folder. I'll save the changes to Java main, and there we have the code for our timed robot. And there we have slightly different scheme. In this case, we have an instance of the class robot is going to inherit its attributes and method from the timed robot. Do we actually call an instance of the robot? Let's see here. We have robot init. When it initializes, we don't call robot itself. We've got robot periodic. We've got a bunch of methods here. We don't have the main method. Let's go take a look at the main class though. And we have the main constructor. And here we're just starting using the robot base to start the robot using the new member of this class. So this is a little bit of interesting syntax. It turns out you don't even need to use this file. It's probably best to leave it alone unless you're really advanced in your programming. I'm going to put some other things here. You can completely program this robot without ever referring to this main because everything is really happening in here. All right, in our timed robot, we're going to put things like definitions of sensors, motor controllers, etc. And up here at the beginning, you see where this list of imports here, we're going to have quite a lengthy list of imports, and we're going to import packages or library references for I'm just going to say information. So an interesting way to look at that, at the beginning, when you're just making the program start out, the robot program doesn't know all that much. But I can do something like this, import edu.wpi.first.wpi.libj. This is our WPI lib library. And I wonder if they have, let's see what we have here. And there could be some kind of command and a bunch of things that happen. I'm just giving an example. Anything that you do in your main program, you have to import an example of it in your or you have to import the information for it using an import statement. Sometimes, oh yeah, there's one that's already installed, gyro. That helps us to know where we're going, and many Roborios have a gyro installed on them, so we can know what direction among 360 degrees or more that we may be heading at the moment. So if we want to use a gyro down here, we have to tell the robot program to load the information about the gyro in. Otherwise, to keep the program execution fast and the amount of code in memory small, we only import what we need. And you'll see by the end of coding your robot, you'll have a bunch of these imports. All right, that's just a little bit about the timed robot. We'll now go to open a new folder. And I'm going to go to the sample command robot. How about this one? May as well just save those changes. I'll come back to that later. And there's my sample command robot. Go to the source and Java, and there's my robot.java and robot container. In my robot container, I'll have a bunch of things happening. And again, I import what I need. And then in my robot container, I have some code here and so on. We're not going to get into that this evening. Suffice it to say, we have different organizations of classes, objects, methods, and all of that within each of these programming schemes used for programming robots. Now, there was a question about the iterative robot. Well, let's try to make a new example of an iterative code base. So I'm holding down Shift and Control and P. We'll go through this later. This is not the focus of this evening. It brings up my set of shortcuts, and here I will make a new project. And oh, I've got a different code folder. Whoa. I'm going to cancel here. I'm not sure what was happening there. All right, WPI lib new project creator. And I'm going to choose from a template, Java template, this time an iterative robot. Or is there one? Oh, it looks like there isn't one now. I guess there were iterative robots before. However, there's a timed skeleton. I'm not so familiar with that, nor am I familiar with the robot-based skeleton. I've only really used time robots and command-based robots. Something I found out the hard way last year, I tried to program a command robot using part of the old command robot code syntax. That took a little while to sort out. There's something that you can also purchase online that's available called the Romy. It's new this year in FRC and allows you to play around with FRC coding without having to have access to the full-sized FRC robot. The Romy is a little handheld robot that you can put on the floor and drive it around using a video game controller and the same programming approach that you would use with the full-size robot. So you can make Romy projects here. This I have never used as it's brand new, and I'm looking forward to trying it out sometime. So I guess I can't do much about the iterative robot because it's no longer here. So I'm just going to make an example of the Romy robot. Let's try a Romy timed robot. Base folder, I'm just going to select one. How about here, sample Romy robot. And there we are, project name, sample Romy robot. Just making a name for it, and I'll put my team number in again, or my previous one. And finally, generate a project. So looking in here, we have our robot.java and Romy drivetrain.java. That's kind of interesting. And we have all kinds of things all ready to go in our sample Romy. So we're not going to talk too much about this evening, just showing how to use the VS Code to select different coding paradigms to complete your projects. So I think that's a good place to finish with that for the moment. In our discussion this evening, we've talked a lot about a key library, well, one key library, the WPI libj. At least we're using it, the library of files and folders that gives us access to programming a robot for FRC. We didn't talk much about some of the other libraries that are available in Java, for example, math and util and different sets of commands that you can import into your program to do certain tasks. I'm not going to talk about them too much right now. Suffice it to say that there are libraries that you can download and or install or just import into your Java program to achieve various outcomes. So we're focusing right now on the WPI libj library, as it has many of the things that we will need to accomplish our robot programming projects or finish them. All right, that brings us to our Java Coopertition, something to keep us going and to develop our coding skill in the next little while. There's something called the limited market game. I made this up for my classes, and I had imagined this over many years. And the idea is this: imagine there are 1 million customers, and every month, every single customer will buy one product. The thing is, which product will each of the customers buy? Well, that depends on the price that each company is selling the product. A company with a high price will not get too many customers, and a company with a low price will get a lot of customers. But because people like choice, some people will buy expensive versions of the product, even though less expensive ones are available. So the question in the limited market game is which companies will adopt a viable strategy, that's you, to make money as a company selling a product. We're going to maybe play an example of this game next week in the class, and in a future week we'll have a Coopertition, perhaps on December 6th. So individuals or teams will code methods to compete in the game. All you need to do to compete is to submit a method. And the design of the game is going to be such that even a very beginning programmer will be able to submit a method, but it's an open-ended sort of thing. So we can see how far can we get in terms of coding to be able to compete in this game. And so next week, we'll maybe play the game and let you see an example of how the game works. And then you can use that information and a few examples to be able to code a method to compete in a limited market game auto tournament. And this is not so much unlike coding a set of code for a FRC robot. You have to produce the code within a method. It takes specific input and it's processed and it gives specific output. And this will be something for us to learn together about how to code robots. And it's for participants of every level. So that's our cooperation. More details will be shared in the coming weeks, and hopefully that will make our interaction in the future sessions more prominent in our session. It's really hard to be interactive with such a large audience. So I'm trying from this cooperation to be able to make it as interactive as possible. And finally, the last idea for this evening is Git Hub. I've already shown you a repository of code on GitLab. It's a related website. And GitHub is not only a website, it's also a program for what we call version control. And maybe I can actually put that into our presentation here. So of course, it also has a website associated with it. I'm just going to present that again. And the purpose and features of GitHub. Imagine that you are now working on your favorite robot for an FRC competition. And so were a few other members of your team. And you're accessing the file, the timed robot file. And it happens that there's only one such file. And maybe 2 or 3 of you make changes to the code at once and hit enter and submit the code. The problem is if you're editing the same file, there's going to be an overlap and difficulties arrive, or that is that somebody's going to lose the code that they made. So to solve this, some time ago, the program GitHub was invented, which among other programs for version control, acts as a central repository of code and allows us to do something called branching and a few other things to avoid repeating, or not repeating, to avoid overwriting other collaborators' code. So each programmer selects a new branch of code, creates a new branch of code, works on that branch, and then tests it separately. And then when the code is working, it can be systematically incorporated back into the program. GitHub needs to be installed on your computers in order to take advantage of the version control features in VS Code. And well, good news, if you have a Mac, you already have access to GitHub. You may have to get some special permission depending on how your Mac is. For example, what you may need to do to get it working on your Mac, every Mac has a command line terminal just like this. And if you go to your search button, which on a Mac is in the top right corner, there's a little magnifying glass, and you can search for terminal. And when you hit terminal, you'll get some kind of interactive screen like this. And if you type in Git on your Mac, it should already be there. If it isn't, you may have to install it, and it may give you a message about that. If you have Linux, chances are you already have Git in your system. If you have Windows, then you also may have to download and install Git for Windows. Oops. And here we are. Here's the website for Git for Windows, and you can download it and install it on your machine. Once you've installed it, you'll also have access to something like a terminal that you see on Macs and Linux machines, which allows you to do much more with your files. We won't probably use too much of the terminal in our discussion here because Git is going to be integrated into our VS Code. So we won't have to use this command line process all that much. However, it may be just worth taking a look at what are some of the basic features of Git, just so you can understand how it all works. So I'm going to go back to this Earth Simulator project. This is actually a Python project, but I'm just going to show you how to download and work with some Git code and some of the basic ideas here. All right, so in my Earth Simulator program, it's part of a repository called Alt-L. I can actually clone my repository using this. And there's the website that I may use to clone this repository. So I'm going to go to my computer's Git directory, and I'm going to type git clone all of this. And it downloads the directory, and it should be there. Did it? Oh. Now this is something that has changed recently with Git. The problem is I need to have access rights. There's more security going on in these programs right now. So in order to get your GitHub working or GitLab, you're going to have to do things like this. First of all, you're going to need an account. So at the moment, you can see I'm signed in. And then once you have an account, you have to go to your settings, and there's something called SSH and GPG keys. This is a whole other computer science topic, but these keys are security measures to keep your code safe from hacking. And in order to access my GitHub repository of FRC Canada code here, I need to install a Java SSH key. Well, actually, I called it that, just an SSH key. And there's instructions for doing that that will work on each computer. And this is how to connect to GitHub with SSH. This is something you may need to work at. So to make sure that you're able to share code remotely. So we need to install Git. And then we need to, as part of the installation, install SSH keys. In fact, I think that's so important. Set up SSH keys. And once you do that, then you will be able to access the code. Recently, GitHub and GitLab applied these security features, which makes it a little bit more difficult to access just any repository of code out there. So we will return to this, and I hope in the meantime you will try to download GitHub for your computer and see how far you can get in setting up SSH keys. I'll give you a little example of what it looks like on my computer. So if I want to know how to set up an SSH key, generating a new SSH key, it gives us instructions. Open the terminal. You need to install Git on Windows to get a suitable terminal to do this. There is my key generator command. And I can go in here and copy and paste it in my terminal. And then I'm going to put my own email here. Now, I'm not actually going to execute this command because I already created an SSH key, but you just hit enter here and it's going to create a key, and I'll show you where it created the key. I go back to my main directory, which is maybe my documents on Windows, or it's under your own name on Mac. And there's going to be a little hidden folder. And you can find these, by the way, just like this. You don't have to use the command line like I'm doing now. I'll go to my main folder here and unhide the hidden files. And then you'll see SSH. And in the SSH, I created two keys when I was setting up my access to GitHub. The public version of the key is right here, and the private version of the key is here. This is the key that I'm going to copy and paste into oops, my program. And that's a public key that is forward facing to the internet. And there we are. Oops. Oh no, probably. Yes, so that's my public key, and there's my private key. And I will probably show this process a few times for you to get set up to be able to use GitHub correctly. So once I have the public key, I can copy it and I can paste it into my GitHub account, just like this. Go back to my account and my settings and SSH keys and new SSH key. I can create, I call it Java SSH key. I copy and paste the content of my public key, and that adds an SSH key. This security feature will hopefully keep your code safe, and this will allow you to now access the code repository without any security issues. So this is perhaps one of the most challenging technical issues that we have, and hopefully you can reach out to other members of your team. I'm also very happy to interact with you by email to make sure that everyone has a chance to get these accounts working with GitHub and or GitLab so that we can share code online. All right. That's what we were talking about, and that's your home fun to prepare code. Preparing to code collaboratively will require us to install GitHub, get a GitHub account, and then set up GitHub with SSH keys. Two-factor authentication is necessary. I had to use my cell phone, and when I sign into my account, I also get a confirmation code by text, which I type in. So that it's a little bit more challenging to use than it was, but it's also for a good reason, to keep your code safe from hacking. So you may want to also take some basic GitHub tutorials, because our sessions here are not about GitHub. I may spend just a few minutes doing GitHub in a future session, just to illustrate what's going to be happening behind the scenes when you use VS Code to update code onto the internet, so your friends on your team can also access your code. There we are. That was a lot for one evening. It took a little longer than I had thought, and be very happy for any questions you may have. There's our references from the first two sessions. This evening, here's just a very particular reference. You may be interested in a free online course for Java programming. You can get it from this site here. Many such things are online. This one looked particularly interesting. It's not for Java, for FRC Java, but it will give you some basic ideas of Java programming. All right, and very happy to answer any questions that may have arisen.
We have lots of interest in the Git that you were just going through, William. People
Okay.
asking about that today.
Sure.
We do have people already asking about whether the slides will be available for today, but
Yes.
I think they'll be posted in the description of the video when it goes on YouTube.
Yeah, we're trying to link everything from the same place, and thanks to Paul for the support. When we have these sessions here, they're recorded, and then we post them on YouTube, and then in the description, the files that we were using will also be available, and the slideshows. So that will be posted hopefully by tomorrow morning. Everything should be in order, or sometime very soon, and so everyone may have access to all of that.
And I did post in the chat where you can get one of these roamies that I have.
Okay, that's good.
And I know there's a bunch in Kingston. Some of the people in Kingston have been using them. It's got a Raspberry Pi on the top, which is part of the roamie thing. And so the idea behind this is that you're going to use this to learn how to code an FRC robot. There's a Raspberry Pi. It's now snapped onto here. And you would use your driver station and your gamepad controller to drive it around. So make your own methods and commands and subsystems. So it's a lot of fun.
And the roaming doesn't have a Rio. The Raspberry Pi acts as a Rio.
Yeah.
And also there's an interesting comment. I don't know if you can even use a Mac for FIC, since the program for building code to the robot has a Mac version. So here's what it is. You can program the code in any computer, and you can share it on GitLab or GitHub. We've done both on my team. And the driver station, the default driver station program, and the one that you must use in competition, you must have a Windows computer for. However, I was able to completely program and operate my school's robot only using Linux by using a open source version of the driver station. So there is, a link there. Thank you very much. There's a link for getting the WPI lib on Mac. So you can do all the Java development code. Many of my students were on teams where some were using Macs and some were using Windows, and they were just interchangeably sharing the code on GitHub to develop the robot code. And then I was also contributing to the code base in Linux. So we had all three types going into our code base.
One of the things that I would suggest from experience is that whatever laptop you're using to code with, that's not the laptop that you're using at your driver station.
A very good idea. Although we broke that rule in my first year of FRC. Maybe that'll be in the FRC outtakes humorous role. We were programming the computer as it was being rolled onto the field. Don't recommend that.
And that happens. The reason I say it's an issue is because the team I was with, teenagers are not known for pulling out the Ethernet cable nicely. And what happened was that when we were at the driver station at an event, the cable was loose.
Oh no!
And the robot kept disconnecting from the FMS, which is the one that runs this thing. So we were constantly having people running over. I don't know what's going on.
Oh no!
So that's just a best practice tip.
Ouch!
That you should keep
there's
in
an
mind.
interesting. Can we use HTTPS instead of SSH? Both are linked to here in the. When you clone, you get an HTTPS or SSH link. So you may try that. But I'm not sure exactly the context of that question. Do you mean using HTTPS to download the code or for other things?
Here, you can unmute if you want to ask the question out loud instead of typing it in.
Sure.
Or for managing team code, like in GitHub, I guess.
Yeah,
Something here says push pull requests.
Yes, I believe so. I've not done it with HTTPS, or maybe not to my knowledge. Maybe I have. I just forgot about it. But I typically set it up with SSH. So there may be two different setups there. So I've just followed the SSH key generator, and then I use SSH, and it seems to work. So there may be a way to do it with HTTPS. I'm just not so familiar with it.
And it should be pointed out that not every team does use GitHub, although we highly recommend it for version control, which William explained. The number of teams that say, oh, we lost our code. Oh, I don't know what to do. I remember a student came up to me and said, the kid who was the programmer on their team locked everybody else out of the laptop, and they couldn't access it to use. So there are reasons why you'd want to have it on GitHub, aside from the fact that teams will post their code after the season, so that you can then go in and
this is an example here.
Other teams have done, right?
Here's our code from last year, and on April 1st, nearing the end of the competition, here's our main code. I think we're using timed robot, so we only have those two files. And here's the robot.java. Whoa, look at all the imports. We had a lot of things going on. We had a gyro, we had solenoids because of our pneumatics. And then here's all our code. The only thing is it gets to be fairly long. And it actually, this is not our final code. This is just an example of a developing code base near the end of the competition. Probably have to go to one of the other members of the team to get their code. But anyway, we have everyone's code recorded and available here. So there's the code being used by another student to do particular things. And some of it is commented out. Most of it is for our autonomous behavior, solving last year's problems. So that's why GitHub is so useful. It turns out last year we had coding going on in China and in Canada on the same team, and we're able to share our code quite handily.
I don't see any other questions right now, William.
Okay. Well, thank you very much to everyone. I'm very happy. If you have questions, please feel most free to reach out by email. And looking forward to working with you. We're hoping to include a Coopertition, sort of to motivate everyone to have a little fun with a little program that you probably haven't seen before because it was invented in my class. But the whole point being to go through the experience of coding a method for the purpose of a competition style code base and seeing how your code works with everyone else's code, playing the little game automatically.
You have a really good question here now, all of a sudden, William.
Sure.
It says, is there any way to debug your robot program if you are not connected to a RoboReel?
Yes, and well, we're going to take a look in future weeks at some simulation. And I haven't used the simulators a whole bunch before, but I have used them. And that is one of the ways to debug it. Another way, for example, if I'm right here, and if I have a robot instead of robot, oh, that actually didn't cause an error. But if I go down here and WP capital I, that's going to cause an issue, isn't it? Oh, it doesn't mind that either, does it?
Well, we're not seeing your code, so.
Oh, whoops, I forgot to share my screen. Anyway, I was trying to introduce errors into my code, and it usually underlines things for you to show you that there is debugging happening. So that's one level of debugging happening right in the coding itself. For some reason, it's not showing me errors right now, so I'm not sure what happened. It should give me an underline, and you may have seen that happening earlier if I make some error in the code. The second level, when you don't have a robot to use, you may also use a simulator and try simulating a robot. There may be limitations to that simulator because there's a difference between your code in a computer and your code operating on the robot, but at least the simulator can also help to identify some of the debugging. But I think the ultimate level of debugging is trying out your robot, of course, with people behind barriers so it doesn't run over anyone's toes. Safety first, and your safety glasses on. You never know if a piece is going to fly off of your robot, but I think that's the ultimate debugging. There is a question on my teacher. I was a teacher for many years at 3 different international schools. And yeah, that's been a great amount of fun. And I've met students from over 70 countries in the process. And yeah, have tied my classes to FRC for the last 5 years. And I will be sharing the link to today's slides and code examples, some of them at least, in the description of our YouTube channel, or our YouTube post rather. So thank you very much to all the participants today. It's been a great pleasure to be with you. And yeah, looking forward to interacting with you throughout the season.
Good night, everybody.